Let's continue talking about alcohol preparation and using alkene hydration reactions. We talked in previous video about Markovnikov hydration, and to remember what Markovnikov is, if we have an alkene such as this, if you do Markovnikov hydration, I'm just doing Mark, you add the H here and here the OH. For example, and there is a couple of, say, conditions or reagents that you can use. Diluted acid is one. And here you have the second method when you want to prevent rearrangement, which is mercuration, demercuration. That will give you that position. But what if we wanted another outcome? Say that from here, I want the anti-Markovnikov outcome, which will be now having the OH at the end. So you're adding again H and OH across a double bond. So that can be accomplished using hydroboration and then oxidation. What is critical in here is that when you get your products, be careful to see the stereochemistry, because the addition here happens in a scene fashion. And that means the H that you're, again, you're adding H and OH across the double bond, H, OH. They need to be pointing to the same side. And I'm going to give you an example of that. So if you were asked, for example, to predict products, and let's throw a particular, say, molecule in which we have that case. Again, use that reagents to obtain the anti-Markovnikov alcohol. And let's do, let's say I'm going to draw molecules. Well, let's say that we're doing first, let's do the Markovnikov product in the anti-Markovnikov product. So if it was Markovnikov, and we use, say, for example, that condition, remember that across the double bond you add H and OH. So what we're doing is adding the H at the, say, the least substituted, so H here and OH here. So your Markovnikov product would be the following. Right? That compound, that alcohol, which is tertiary alcohol. Now, the anti-Markovnikov product, let me throw that over here. We have then the OH here, so at the more substituted, and the H at the least substituted. So drawing the structure now, we will have initially, let's just draw that without any configuration whatsoever. But we're going to add that in a minute. So what we said, anti-Markovnikov is H at the more substituted, the OH at the least substituted. So that's your alkene. However, we see here that we two chiral center. We have two chiral centers. This is one, and that's another. We also said that this reaction happened in a scene fashion, meaning that in that molecule we should have, say, if we have the OH here on the wedge, we should have to the same side the H, which means that the metal should be in dash. Again, this drawing means that you have the H and the OH to the same side. Same side, we said it's seam. And we will draw them. Typically, we don't see the H in the drawing. So what you see as a result, when you see that in, say, drawn in books, we will have that. That is saying that the H is in wedge, so it is to the same side. So it would be wrong to put, say, for example, two wedges or two dashes. Also, you're forming the other possibility, which is having, and now I'm going to erase this to make room for the other. You can have the enantiomer to that molecule. And so again, paying attention of the stereochemistry, the other molecule we have again is anti-Markovnikov. So you will have DOH here, say that you have now that on dash, that means that the H is also on dash, and therefore the metal is on wedge. So these are the two products that you expect from the reaction of these alkene from the anti-Markovnikov pad. So again, anti-Markovnikov is, you will add here the H at the more substituted, DOH at the least substituted, and pay attention how you put the H and the OH because they need to be to the same side.